Okay, so next we want to discuss the telescope. In a telescope, we are looking at an object that is very far away. So that means that the distance of the object is effectively infinity. In a telescope, we have two lenses. So the first lens is the objective, and it collects light and creates an image. And a second lens is the eyepiece, which is used to form the image produced by the objective and turn it into an image that forms an image on our viewer's eye. Notice that both of these lenses are converging lenses. One way of thinking about this is that the objective forms an image, and then the eyepiece acts as a magnifying glass that allows you to view the image as large as possible. So the first lens, the objective, takes light from infinity and focuses that light at the focal point of the objective. The light continues through the focal point of the objective, and then the light is then straightened out by the eyepiece. So it looks like the light is coming from infinity again. For this to work, the focal point of the objective and the eyepiece have to be the same. Now, notice the distance of the two focal lengths are very different. It's that the focal point of the objective and the focal point of the eyepiece are connected to each other, so that means the length of the telescope, so the distance from the objective lens to the eyepiece, is the focal length of the objective plus the focal length of the eyepiece. We should also notice that we want as large of an objective lens as possible. One of the big uses for a telescope is that you want as much light as possible to go into your telescope. So the larger the lens, the better. In fact, a lot of the value here is that you're collecting more light, so that might be even more important to the quality of a telescope than the magnification itself. To find the magnification of a telescope, we divide the focal length of the objective by the focal length of the eyepiece. This should sort of make sense. The smaller the focal length of a magnifying glass, the larger the magnification. So the eyepiece is acting as a magnifying glass, so the smaller the focal length of the eyepiece, the bigger the magnification. As for the objective, the larger the focal length, the larger the magnification. Don't forget that the length of the telescope is the sum of the focal length of the eyepiece and the focal length of the objective. Okay, so we've got a problem here. Our telescope has an objective with a focal length of 40 centimeters and an eyepiece with a focal length of 0.5 centimeters. So we want to find the magnification. To do that, we divide the focal length of the objective, which is 40 centimeters, by the focal length of the eyepiece, which is 0.5 centimeters, and we get a magnification of 80 times. So remember, if you know the length of the telescope and you know the length of one of the focal lengths, say you know the focal length of the objective, and that means that the focal length of the eyepiece is the length of the telescope minus the focal length of the objective. And then once you know both focal lengths, then you can find the magnification by dividing the focal length of the objective by that of the eyepiece. All right, good luck and with your question. And next we'll go through the compound microscope.